Hello and welcome to this tutorial. We are continuing the series of Spark plus PySpark. Today we are going to discuss about Spark memory management. Since we all know Spark is a memory based data processing framework, so understanding the memory management is very important. To understand the memory management of Spark, we are considering some Spark configuration with one driver and three executor. So I have one driver here. I'm considering this driver has 5 gigabyte of memory and three executors where I'm considering each executor have 10 gigabyte of memory and each executor is equipped with a 4 core CPU. So this is just a consideration to understand this memory management in detail. As we consider that each executor will have 10 gigabyte of memory, so I'm expanding any of one executor to understand the memory management. So this is how one executor is going to look with all the available memory portions in it. So if we look into this Spark executor container, we will primarily have three blocks. First is this on heap memory, second is this off heap memory, and third is going to be this overhead memory. So we are going to go in detail about each and every kind of memory. So if you look here, this on heap memory is going to be further divided into four portions, which are going to be execution memory, storage memory, user memory, and reserved memory. Now, the main thing that we need to understand is that most of the Spark operations will run on this on heap memory, which gets managed by JVM. So JVM is nothing but it is a Java virtual machine. Now you might be thinking how JVM manages this memory. We are working on Spark. How JVM comes into picture. So let's understand this in detail. JVM stands for Java Virtual Machine and it is like a virtual computer that is used to run the Java programs. Spark is written in Scala language which runs on JVM and JVM serves as an execution environment to Scala. Whenever we write code in PySpark, we are using wrapper around Java APIs of Spark. So this is how inner execution of PySpark happens on JVM. It justifies how in-heap memory gets managed by JVM. So it gets managed by JVM indirectly because Spark is written in Scala and JVM serves as an execution environment to Scala. That's why JVM manages this on heap memory. So this was one thing. Let's move into these four sections and understand each and every section in detail. So first section is this execution memory. On this execution memory, executions are going to happen. So joining execution, shuffles, sorting, group by, these kind of operations are going to happen using this execution memory. Second is storage memory. So this on this storage memory, RDD, data frames, caching, all these things happens on this kind of memory. This also gets used to store the broadcast variable. So RDD data frames are going to be stored here on this storage memory. Broadcast variables are going to be stored on this storage memory. Also, some kind of caching is going to happen on this storage memory. Third one is user memory. On this user memory, user objects, variables, user defined functions are going to be stored on this user memory. Next is reserve memory. So this is the reserved part of memory that Spark uses to run itself and for storing internal objects. So this is somehow a kind of memory that is reserved. Spark uses it to do its internal operations. Next is overhead memory. So this is the overhead memory I have shown in this diagram. Overhead memory is used for some internal system level operations. So we are not going in much detail about this overhead memory. Let's understand how memories are going to be partitioned in our case, where we considered each executor is going to have 10 GB of memory. Till here we understood the description of each memory block under the executor memory layout. Now we are going to understand which portion of memory is going to take how much space. So as we know, initially we assigned 10 GB to the Spark executor. So this spark.executor.memory is going to be 10 GB. Now we are going to talk about the spark.memory.fraction. So this fraction is going to be 60% of the total assigned memory, that is going to be 6 GB. And this spark memory fraction is going to be 6 GB. So if you see into the diagram, you will find the spark memory fraction. So this is spark.memory.fraction, that is going to be 6 GB. And combinedly, this execution memory and storage memory is going to be termed as unified memory. Now we are left with 4 GB because we assigned 10 GB to the memory executor. So far we have spark.memory.fraction equals to 6 GB, and 50% of this spark.memory fraction is going to be spark storage fraction memory. So that is going to be 3 GB out of this 6 GB. So 3 GB has been assigned to storage memory and 3 GB has been assigned to execution memory. Moving ahead, we are left with 4 GB, out of which this user memory is going to take 3.7 GB and reserved memory is going to take 300 MB, because now we are left with 4 GB and we know that this reserved memory is going to take 300 MB and this is going to be fixed. So that's why automatically 3.7 GB of memory is going to be assigned to the user memory. So this is how the memory fraction of each memory block is going to work under on heap memory. Let's move to overhead memory. Overhead memory will be extra memory from the spark.memory.executor memory. So initially we considered 10 GB to the spark.memory.executor memory, but this overhead memory is going to be extra from this 10 GB. So this overhead memory is going to be maximum of 384 10% of Spark executor memory. So 10% of Spark executor memory is going to be 1 GB. That is why we will have overhead memory as 1 GB. Off heap memory. Off heap memory will be disabled by default, but we can enable it by assigning about 10 to 20% of executor memory. Again, this off heap memory is again going to be 1 GB. So if I tell you in nutshell, now we have 10 GB memory assigned to the on heap memory and 1 GB memory assigned to overhead memory, and rest 1 GB memory again assigned to the off heap memory. So this is how final numbers are going to look like. Now you might be thinking we allocated 10 GB memory to on heap memory and have not allocated anything to off heap and overhead memory. Then how does these two partitions gets memory? Answer is executor allocates memory only to on heap, but when Spark requests the cluster manager for memory, it is going to request added off heap and overhead memory as 10 GB plus 1 GB plus 1 GB equals to 12 GB. So, when Spark requests memory to cluster manager, it not only requests for on heap memory, it also requests for off heap memory and overhead memory. Let's discuss more about this unified memory. As we discussed, execution memory when combined with the storage memory is going to known as unified memory. And this unified memory is going to be termed as unified because of dynamic memory strategy. Let's understand what is this dynamic memory strategy. So this feature allows to adjust memory between execution memory and storage memory. If execution wants more memory, it can simply use some of the storage memory, and if storage memory wants more memory, it can use execution memory. Let's see how exactly this works. So this is the separation bar between execution and storage memory, and this bar can move dynamically based on the requirement of storage memory or execution memory. As represented in the above diagram, this separation bar can move as per requirement from execution or storage memory. So this was all about the Spark memory management. Thank you.